Hey guys, I'm going to go through this pepper moth simulation with you because I noticed that maybe you may have issues if you can't log on to the site through your phone or computer. So I'm just going to click on it with you. All right, so I'm going to copy and paste this link. This link is also in our classroom website, by the way, just letting you know that. Okay, cool. So I just click it and I allow. So the first thing you're going to do based on the assignment, so read background information. Remember, use to seek to respond here. And basically everything that you're going to read is already on here, but I'm going to read it out loud for you. So Dr. Kettlewell's test. Science requires that theories be tested to see if they are supported by evidence. During the 1950s, Henry Bernard Davis Kettlewell ran a series of experiments and field studies to find out if natural selection had actually caused the rise of the dark-peppered moth. Dr. Kettlewell was an entomologist, a scientist who studies insects. In 1952, he was named a research fellow at Oxford, one of England's premier universities. He spent the rest of his life studying peppered moths and other moths known to turn dark through industrial melanism. Okay, so these moths turn dark for a reason. So scientists test theories by making predictions based on the theory. They then test prediction to see if what they observe matches their expectations. Dr. Kettlewell felt that if natural selection caused the change in the moth population, the following must be true. So heavily polluted forests will most likely have dark peppered moths. Clean forests will have light peppered moths. Dark moths resting in dark trees are more likely than light moths to be eaten by birds. But the reverse is true if it's like on a lighter tree. So dark moths released into polluted forest would live longer than light moths, but die sooner in clean forests. Okay, so meaning that the lighter moth survives better in lighter environments, dark moth survives better in darker environments. Amateur entomologists across England helped Dr. Kettlewell map the population of moths. Their work showed clearly that high populations of dark were found near industrial cities that had pollution, like because of the smoke, right? Smoke is dark. So in countrywide not darkened by factory soot, the dark moths were rare. Dr. Kettlewell compared this information with studies on the moths done in the past. It was clear that dark moths were almost completely absent before the Revolution, the Industrial Revolution, which you've learned in social studies. Now they were found only where the forests were polluted. To directly study bird predation on moths, meaning like how the birds ate the moths, Dr. Kettlewell placed light and dark moths on the trunks of trees where he could observe them. He recorded the times a bird found the moth. He found that dark tree trunks, birds were twice as likely to eat the light moth as a dark. The same birds would find the dark moth twice as often if the bark on the tree was light. This supported the idea that dark moths had a survival advantage in a dark forest. Dark moths survive better in dark, white moths survive better in white. Okay, so here it is. It also tests the idea of dark moths in forests. Basically, it's what I told you. That's what I told you. That's not as important. So his years of work made excellent case for natural selection. Every prediction he made withstood his test. So dark in dark, light in light survive better in light. And in dark forests, the dark peppered moths were shown to have a survival advantage over light moths. Birds were twice as likely to eat light moths as a dark moth. Rare before factories were built in England, their increase in numbers was shown to be related to pollution. So natural selection was the best explanation for the change in moth population over time, right? So that means like if the birds, if they were in a darker place, like the moths were in a darker place, these moths, and then the birds flying over were trying to eat, the moths, they would find the white moths more than the dark ones in a darker place, okay, because the dark ones blend in better. So watch a natural selection in action by going to bird's eye view. You'll do that later. All right, so I'm just going to show you some images of the peppered moths because I have 30 seconds. And the white moths. Okay. And here they are. Like, as you can see, there's like images of them all over, what it's better suited. Like if you were to go here, this is a lighter environment, so you can see I can hardly see. This is a moth. I can hardly see it. All right. All right. Bye, guys. I have to go.